Hello students, I'm Mr. Reef, and I want to talk to you a little bit about physics in general. So the first thing I'd like to talk to you about are the goals of physics. Physics is a science, so it tries to provide explanations of the natural world. Physics is probably the broadest of all the sciences. It tries to tie together events and phenomena on all different scales, from tiny to the size of the universe. So in that respect, it's quite a bit different from other sciences that you might be familiar with. For instance, biology deals with the science of living things. Chemistry largely deals with the science of atoms and molecules and the components of atoms and molecules. So physics is much broader. Physics studies the interactions of energy and matter, and it uses a number of different concepts like momentum, angular momentum, charge, and mass as ways to explain how the universe works. That's a little bit broad, maybe a little bit indefinite, but as we go through the year, you'll get a better idea of what I mean by that, I hope. Physics has a particular language that it uses, and by that, of course, there are vocabulary terms. I've already used several of them, like mass, charge, etc. But more than that, it has a set of representational tools. For instance, if I draw this on the board, you'd say, well, I've drawn a face, a smiley face. But it's obviously not a smiley face. It's just a circle, two dots, and a little swoop there. But that represents to you a smiley face. So it's a form of language. You might even see that and interpret it as being a person. If I drew several of these, you might say, oh, he's really happy. Or you might say there's several smiling people there. Okay, well, physics uses symbols and representations similar to the smiley face in concept, but quite a bit different. So there are many terms that we use in physics. As I said, I used some of them already: momentum, force, etc. And so those are words that represent a particular set of ideas in a physicist's mind. We also use pictures. I'm a terrible artist, but throughout the year, you might see me drawing a stick man running. This is supposed to be a stick man running. Stick man running, and you say, oh, okay, well, there's somebody running. That's part of the setup of the physics problem. So pictorial is one set of representations that we might use. Another is to draw a graph. That might be a typical linear graph that you're familiar with symbols on the axes representing what we're talking about. We also write equations. That's another representational tool. So this is one of the first equations that we'll learn from the AP equation sheet. Don't worry about what it means now, but each one of these symbols has a particular meaning in physics. And then we also do I would call this a mathematical representation, this a graphical representation. We also do, in addition to just a drawing of the sketch, simplified drawings where we represent objects as just a dot. So if I draw a series of dots and I say, this is the positive x-axis, you would interpret that, once you know the language of physics, as the object was in different places at different times. Another tool that we also use in our language of physics is obviously words and descriptions, as I'm doing right now. So these are all part of the language of physics. You can view them as conceptual or representational tools, but of course physics uses other tools. Measurement is one of the most important components of science, observation and measurement, and so we use tools like meter sticks, balances, and of course much more complicated tools to measure the physics quantities and ideas that we're interested in. So when I say a physics quantity, that is a concept, going back to the language, that a physicist is interested in that can be measured. So let me erase a little bit. If I say mass, sorry, I chose a marker that's not very dark. If I say mass, that's a quantity. It's measured in a unit, kilograms, kg. And it has a variable that we often use, lowercase m, or it might indeed be an uppercase m. So the tool comes in when you want to measure it. You'd measure mass in kilograms with a balance. The variable comes in when you want to use a representational tool like an equation. And the quantity is the big idea. We'll talk a little bit more about what that means. And then the last thing I want to say to you about physics is that physics has a culture. So the culture has many different components, but two that I'd like to stress right now, and that is that we're all in this together. Physicists do lots of their work in collaboration with each other. In fact, at times there may be hundreds of different physicists working on the same project. So in this classroom, we'll also collaborate as best we can. The other thing I want to mention about physics is that constructive criticism is a big part of it. And that is a big part of science as well. So in other words, in physics, we value being told when somebody questions our ideas, our conclusions, and our work. That makes us stronger, makes us better, makes the work better. So somebody should question your work at pretty much every point. That doesn't mean they're rude or they're mean. It means they're just trying to make sure that you've really done things right and that you fully understand what you're doing and that this is the best physics work you can do. So I might ask you questions about your work. Other students might ask you questions about our work. And the fact that that's making us better is the culture that we want to build in this class. Thanks for watching. Remember, what one fool can learn, another can.